Welcome back to another rousing rendition of We Ran Out of Time in Class, so let's continue the lecture online. All right, so we've been talking about naming organic compounds. We've gone through alcohols, we've gone through the other ones. So right now we're going to talk about aldehydes and ketones. So write the IUPAC. And common names for aldehydes and ketones, draw a condensed structural formula when given their name. So we should be able to do one and the other, and you guys have been doing pretty good at this so far. So let's just continue on with our good luck. So we've got what's called the carboxyl group, which is a carbon and an oxygen tied together with a double bond. So we call that a carboxyl group. Now, in the case of aldehydes, okay, it is when the carbon grouping bonds with one carbon and a hydrogen on the end. And then we've got the other group, which is the ketone, when the carbon goes between the two hydrogen positions, like what we see here, okay? And we'll talk about it. Like in this case of a ketone, we're going to add O on the end, and in aldehyde, we're going to add an Al on the end, an al group, all right? So, to name an aldehyde, the IUPAC name replaces the E in alkane named with Al. Okay, so common aldehydes. Here are our first four. We've got methanal, ethanal, propanal, and butanal. Okay, and common name for aldehyde, acetaldehyde, propium aldehyde, and butyl aldehyde. Okay, but technically the IUPAC name would be methanal, ethanal, propanal, and butanal. And if you think about it, okay, well, meth 1, meth 2, prop 3, but 4, pentanal, we could say 5 carbons, and we're always talking about the backbone. Remember, we're talking about that carbons in that base chain. We may have other things going on, like a fluorine or a chlorine coming off. We may have another methyl groups coming off to either side. So we're only talking about what's in the backbone of these chains. So we're going to do aldehydes first, naming the largest carbon chain by replacing the E in the alkane name with an Al. All right. So name and number the substituents by counting the carbonyl groups as carbon being 1. All right. So if we look here, all right, we would tell ourselves that we want to start with this carbon. In the case of ketones and aldehydes, we are going to start where the grouping starts. So we're going to start with on the left, and we're going to count 1, 2, 3, 4, and 5. Okay, so we've got pent, right, and we're going to add an Al. Okay, pentanal. So that's great and all, but it's at the 1 position. But we also have this chlorine to deal with. And what do we know about chlorine? Well, if we've got a chlorine in an organic compound, we name its position, and then we go chloro. So this would be, well, 1, 2, 3, 4 chloro pentanal. All right, let's check ourselves out. Okay, well, 1, 2, 3, 4, 5, yep, and it's pentanal. And the chlorine is located at the 4 position, so it's 4-chloropentanal. Easy as that. Don't overcomplicate it. If I were to have switched the chlorine to another position, start with that carboxyl. So start with that carbonyl group, and then we work our way back. The vanilla plant is a member of the orchid family, thrives under tropical conditions in many species, but vanilla planifolia, or the Fraganus, we'll go with it, is considered to produce the best flavor, okay? The seeds and the pods are used as flavors in desserts, such as ice cream, custards, chopped up mixed with an ethanol water mixture and filtered to make vanilla extract. So when you extract something, you're pulling out the essence or the particular grouping itself. Vanillin, vanilla, it's right here. And notice that it is attached to a benzene ring. So that's going to make it what? An aromatic. That's right. I heard you guys say it. I could feel it come through my mind. All right. So let's talk about ketones. The name for ketone, the IUPAC name replaces the E in alkane, named by one. Okay, literally like ketone. All right. So, or I should say on that one. Common names identified with alkyl groups attached to the carbonyl group is the alphabetical order and adds the word ketone. So let's take a look how this works. All right. Well, here's our functional group right here. Notice it's between 2 carbons. Okay, so that's what we're looking for. That's the key. All right. So we count 1, 2, 3, 4, 5, 6 carbons on the backbone. That's going to give us the hexanone. And then we've got this pesky little chlorine there. So it's at the 5 position. So it's going to be 5-chlorohexanone. All right. It isn't overly complicated. These are just rules to be followed. So just make sure we write these down. We have them on a little cheat sheet, a little sheet of paper. But really, it's a memorization game. Remember, this is much different than the naming of inorganics, as we have our own unique for organic materials. Organics dealing with carbon and the backbone. All right. So we have the 2-hexanone. Should have said that. Okay. So that becomes 5-chloro-2-hexanone. And, so that's where we're at, 5-chloro-2-hexanone. So not too difficult, just some rules to remember. Thanks, guys. And I'll be back on with more organics here in a second.